Hi everyone. Thank you for, this is one of the last sessions of NDC London. Has everyone enjoyed London so far, NDC? Yep, some like tired nods of heads. I love the NDC conferences, generally really well run. But every time I go to these conferences, I hear about all these amazing new tech stacks and new processes and new things that you can do. And I know from my history that sometimes you learn about all this new stuff and then you go back to your company and get back into the legacy code that's 20 years old and do things exactly the same way because you don't have the power to change everything and do a file new project. And that's kind of what's driven the development of this talk. It's kind of an understanding that it's great if you're a greenfields developer who can do a file new project every time you start, but that's not the majority of people. So I'm talking about brownfields. We've all probably heard, have you heard the term greenfields development? It's basically where you get to choose how you're going to do stuff, and it's at least several weeks before you decide that you made a mistake. But brownfields, I kind of like to think of it as software and processes and things that if you were to start them again, you know what you would do differently. So it's mature enough that you're like, I know this is bad, but that's the situation we're in at the moment. So the message for today's talk is really that you can take what you have as brownfields development and start moving into a better story for DevOps. And that's what I want to talk about. So I work for a, thank you. Cheers. I work for a company called Octopus Deploy, which is based in Australia, so hence the beer. But I've recently moved to Toronto, and it's much colder. But before working for Octopus Deploy, I was in consulting, and then before that I was in government organizations and in finance and things like that. So I've seen a bit of a range of processes, definitely some organizations that are extremely brownfields stuff. So just as a question, think about the products that you work on now, so the bit of software you work on, assuming you're a developer, or the bit of software that you are involved in if you're not a developer. Who, if you think about that code base, who is working on a code base that is more than a year old? Okay, that's probably slight majority of the room. Anyone more than like 2 years old? 5? People aren't putting their hands down. How would I know? How would you know? Yes. If it's, yeah, so, and that's the scenario. That's the reality that a lot of people are in. So the first thing I want to say is that it's okay. I understand. I've been there before. But it's really about what you do after that. If you go home and say, well, all of that stuff I learned is too hard to implement here, I understand that mentality, but by making small steps forward, you can actually improve your DevOps process. So I'm going to introduce a couple of individual things that you can do, even if you don't have the power to change the company that you work for or the organization. All right, so first, this is an international conference, and DevOps is in my title. So I think I'm legally obliged to give you my own definition of DevOps. And even if I'm not, I'm going to, because every other bastard gets to do one. So this is how I think about DevOps. It's really 4 things. It's working together to put the right stuff in the hands of users faster. So I split them amongst 4 lines. You'll notice there's no products there. There's no tools there. It's just this idea of working together to get the right stuff in the hands of users as, you know, on a fast cycle. So working together is kind of the biggest thing that people get wrong. Who here has a department in their company which has DevOps in the department name, like the DevOps Team or the DevOps something like that? Yep, I saw a couple of reluctant hands. The solution to 2 teams who don't work together and don't talk to each other is not a third team in the middle who also doesn't really talk to them, right? You kind of got to get out of this silo mentality and actually work together. And I'll talk about some ways to do that, even if you're not the guy in charge of how the teams work. So part of what those people should be doing is getting the right stuff. And I'm not just talking about the highest priority work items on your backlog. That's not necessarily the right stuff. The right stuff also incorporates things like working software that doesn't fail tests and software that actually does what the person expects rather than what is written down on the sheet. And to do that, you really need to measure what's happening in production as well. If you release a feature which is technically correct but doesn't really even get used because it's so broken from the eyes of the user, that's not the right stuff. So you're putting the wrong stuff into production. So we need to focus on the right stuff. This is a big one for me, is getting it in the hands of the users. If you have beautiful working software on your development laptop, then it's completely useless, all right? If it's not in production, it doesn't count. We're not shipping your machine, we're shipping stuff in production. So getting it to production is the only thing that counts. And DevOps is really about doing all of this safely but faster. And if you can do it faster, you get into this nice cycle, which we call the, I can't remember the name. This nice cycle, virtuous cycle, here it is, where you're delivering smaller bits on a faster cadence, which means that there's less risk every time you deploy, because each thing you deploy is just a small change. But you can do it faster, which means that if you do make a mistake and it's in production, it's much, much easier to push out a fix rather than working out when you can schedule a backup and restore, and maybe you have to wait till the next 3-month window to deploy. So getting into this virtuous cycle to get things done faster is really important as well. So this definition, which I'll keep referring to, is kind of what I'm thinking about as DevOps. So moving towards this idea in an environment where there's already a process and already an architecture, and it's just not as easy as just deploying to production. So assuming that people are on board, the question is, how do you actually do that if the existing system's there and the architecture's bad and the deployment process is horrible and there's silos and you have no control over it? So that's what I want to go into, a couple of tips. Number one, or step 0 probably, is to establish a baseline. Work out where you are right now. In business terms, we talk about a gap analysis. So this is where we want to be, and then you have to evaluate where you are so you know which direction to go in. And the same thing kind of applies here. You need to evaluate what you're doing right at the moment. And the idea is not to point fingers or judge people. It's really just to work out what actually happens in your organization. So how do you develop as a team? How do ideas get from somebody saying, we need this feature, all the way through to production, and what happens after that? Like, what happens when it's in production? From a development point of view, that includes things like, how do you actually build your software? Is it Milton's machine is the build machine, and if he's away, we don't deploy, because he does the compilation, and then we RDP onto the servers? How do you actually deploy them to production? And it's an information gathering thing as well. So when you do a deployment, when everybody comes in on a Saturday and that 3-month block, and they come in on a Saturday and they hack through a deployment, have a scribe there writing down exactly what happens. Not this is what the document says is going to happen, but actually what happens. If there's something that goes wrong, you need to know about it so that you can get the direction forward. So this is kind of the initial one. It's also useful to look back on this after you start making improvements and see, whether you've made actual improvements that have led to faster and better software. So once you've done that, as a developer and as a development team, it's a good idea to get your software into a good state. So if somebody now came to you and said, right, we need to start deploying your software 10 times a day, that's not feasible for a lot of people. It's just not. You can't just take what's existing there and just keep pushing it out. So you can't do that, but you can get your software slowly into a better state so that that is possible in the future. So a couple of things that we can do. Number one, get to one code base. Now, I mean this in a couple of respects. There was a company I did some work for where I did some consulting for them. I went and I asked them what versions of their software were running at each of their customers. So one bit of software running the same software in 30 customers. And I was met with genuine laughter because they didn't really have this idea of the same software running at the different customers. If that person had a bug, then you get their code and you make that change and then you redeploy it to them. And then if it's something that applies to everybody, then you make the same change on everybody else's code base. Now, whether that's a branch that has variations in it or actual different source control, which was the case with them, it's important to try and bring your software back to one code base. Now, even if you don't deploy that across several customers, having one branch is a really good idea, especially for your release candidates. So Martin, who was in here before, was talking about short-lived branches, and you should be on master or main or whatever you call, or trunk, whatever you call your main branch as much as possible. And yes, branch to do bigger pieces of work, but they should be short-lived branches and then pushed back to the main tree as much as possible. So having one piece of code is really important for getting deployable software that's predictable when you deploy it. But to do that, you need to isolate the variations. So anything that's a change between different implementations, whether that's in test and staging and production, those variations, or whether it's between 5 different companies. You need to isolate those changes so that you can do something about them. So as an example, this is kind of similar to code that was at this company, right? So they have a method, get with sales tax, and 3 different ways of calculating that. So if they're deploying to a New Zealand customer, they'd comment out the UK one and uncomment the New Zealand one and then compile and deploy, right? I'm sure that nobody's doing anything like this here. But that's not a great way. It's really hard to verify that you've fixed everything that you need to fix. This is slightly better. Now we've got one variable called country, and based on that, the code is in one place, right? It's in one location. But there's problems with this as well. If you need to change the way that the New Zealand tax rate is counted, for example, the person who's working on that code is essentially preventing you from pushing this out to production until their work is finished and complete, even if you're not deploying to New Zealand. So that's a consideration as well. A better way of doing it, dependency injection, abstracting these things away. It's still in the same code base, but you have a different implementation for your different things. So finding those variations and isolating them, but keeping it in the same code base is a good strategy for going forward. Now, you could still have this problem of, you know, if it's in New Zealand, or just a set in the a line in the initialization saying, we are in the UK, and then you comment that out and say, we're in New Zealand when you do the compile. You don't want that either. So the next thing you have to do is you need to externalize any of these configuration things. If there is something in your code that makes a decision about what environment you're in, or what customer you're deploying to, or something like that, that setting should be external from your compiled application. Now, I'm a fan of configuration files that's just like JSON or XML or YAML or something like that. But you can also put it in a database. You could set environment variables when you do your deployments. But having that configuration external means that you can more predictably deploy the software. So the idea is that you set the configuration when you deploy. So if you're pushing the same software out to staging, then you set your configuration up for staging. So the software knows how to read that, and it knows how to set everything up for the staging environment. You read it at runtime, so you pull that in when the code is running and work out the code path that you need to go down. And then if you're doing dependency injection, you choose that implementation based on the configuration. So as an example, you might have some configuration that sets the location. Or you might have a database that's being used, or a connection string, or whatever else. But any variation between actual deployments should be configurable externally from the binaries. And there's a good reason for this. The good reason is that you should be aiming to build your application once and deploying those same binaries to all of your different environments and all of your different customers. It's really, really common for people to have a build server where when they do deployments, they will get the build happening, it'll spit out some binaries, and then they do a different build and recompile again for the production one, and then they'll push that out. Now, usually that's going to go okay, but there's always the chance that something has changed between those two compiles. So if you pushed out binaries to test and everything works perfectly, and then you recompile for production, those binaries are different binaries. It's different compiled code that you're now deploying for the first time ever. So by externalizing all of these configuration settings and all of these variations between your environments, it means that you can deploy the same bit of code through your environments and to different customers. So you're deploying the same bits everywhere. So you know what they look like. You know that the ones you've tested are the ones that are in production. And you can test the same deployment process everywhere as well. So not just does the code work, but does the way I deployed it also work? And that's really important as well. To do that, you kind of need a versioning strategy. Now, this could be an entire hour-long talk by itself, so I'm not going to go into it too much. In general, people will say use Semver if you can. Does everyone know what Semver is? A couple of people. Generally, like in its most basic sense, it means you have a major.minor.patch version, and there's strict rules around when you're allowed to bump those versions. So if you have a breaking change, you've got to bump this version number and so on. I think Semver is great if you do it, but really the only thing I care about is these. Every time you compile your code, there's a unique version number. And that version number is higher than the previous version number. And what this gives you is it gives you the ability to look at a compiled bit of code, which is version 1.2.3, for example, and just know that that is newer code and different code than 1.2.2, for example. So every time you make a change and recompile, new version number, and be able to place those versions so that then you can tell which one is the newest version. And because we're on the same code base, that one trunk, then you don't have to worry about versions of different branches and things like that. You're just on the one code base. So I think both of these versioning strategies are perfectly acceptable. You can see how they progress, and you can see which one's newer, and as long as there's no duplicates of these lying around, then that's fine. But really, I just care about these two things. The last thing I want to say about getting your software in a good state is that it's important to measure what's going on in production. And honestly, there's not really a good excuse for not doing this. Some of the companies that I've worked with before, the way they find out there's a problem with the software is they get a phone call from their customer. Or they get vague bug reports about it's feeling slow now after you made that last change. But you don't know this until somebody tells you, and what help is it's slower than it was before. Not a lot. But there's countless frameworks, countless free tools, things like that, that can just put some metrics around what's going on in your application. Even if you're just spitting exceptions out to a log file and monitoring how big those log files get, how fast. That's something. It's something that lets you tell whether something you have just deployed has made an improvement or has introduced something bad. So start doing that as well. So getting to a good state, even if you're not in charge of the company, you can still push towards one code base. You can still start to isolate those changes and externalize the configuration that does that work. You can build once, deploy many. So who here has a build server for their application? Okay, that's most people, which is awesome. That's really good. If you don't, it's generally one of the easiest and best things you can do with your application. Rather than right-click compile or F5 or whatever it is that you do in whatever language it is. Rather than doing that, knowing that there's something building your application and going to let you know if there's a bug or if there's something wrong with it, that's really, really important. So do that. Versioning right and measure what's happening in production. And not what's happening on your local machine necessarily, but what happens in production is really important. Otherwise, you can't fix it. So we're kind of moving towards getting the software in a good state. The reason we do that is so we want to deploy this software without a lot of drama, without that Saturday everybody there for 48 hours eating pizza in shorts and t-shirt, which probably doesn't happen here, in jeans and jackets. To deploy it without a lot of fuss. Like, it's not a big deal to push to production once you get this stuff right, and it shouldn't be. So a couple of things that you can do here. Number one is try to get to a stateless deployment. So what I mean by a stateless deployment is basically just one where you're not relying on the state of the server or the environment that you're in. So who here, when they do a deployment to production, it's a very special, different thing from all the test deployments. I'm seeing some nodded heads. Yeah, a couple of hands. Ideally, your deployment to production shouldn't really be any different than the deployment to your test environment, ideally. And sometimes it is, because production is this precious place where you can't update any patches, you can't make any changes to it. So the last time anybody touched that server was 6 months ago, and I don't really know how it differs from staging. It's probably close, but there's going to be stuff that will happen when we deploy to production. So ideally, you want to get to a state where that's not the case, where deploying to production is just like deploying to any other environment. So as an example, This is a pretty common pattern where you'll have your version on the application, and by app version 1, I mean that version, all of the framework updates, the .NET framework updates, the dependencies, everything that you need to run that application. And then when you deploy version 2, you're deploying the changes over the top. So you might just change the files that have been modified, or update a couple of things and then change the configuration here or something like that. Same with version 3. Ideally, what you want to be able to do is deploy version 2 whether or not version 1 exists at all. Now, under the covers, that may actually be doing the same thing as before. It might deploy version 1 and then deploy the version 2 patches. But you want to be able to say, there's a fresh new machine, just deploy version 2 of the application. And same thing, obviously, for version 3. Now, this is harder than it sounds sometimes. I know it is. But part of that first data gathering thing that we did in step 0 was to work out what actually happens when we deploy. And if you can build those, this is what actually happened when we deploy into your process, then you can do it next time you do a deployment. You know, we thought that we were just going to copy the files over and restart IIS and everything would be fine, but actually what happened is this folder was left over and it was locked, and so we had to unlock that. If you know about those things, then you can get much closer to this state. You know that that can be part of your build process. Now that's easy for binaries as well. Generally just copying the new stuff over the top of the old stuff will, for the most part, work. But it's much harder for external dependencies, things like databases. Databases are generally the hardest part of a deployment process, an automated deployment process. There's a couple of reasons. One is that it's such a single point of failure. I mean, if you have 2 web servers and you upgrade one and it doesn't work, you can just leave the other one handling all the traffic while you work out what you did. The database is usually just one location. The other thing is, once you change the schema of the database, it's very difficult to undo that change often. So there's a few ways that people will do these changes as well. One is migration scripts. So every time you make a change, you have a script that moves from the previous version to the new one. If you're deploying to a fresh machine, then you run script number 1 all the way through to wherever you are now. If you're deploying version 2 to version 3, then you run those scripts. So you can still deploy holistically, you can still deploy the whole thing, but the migration script means that you are always moving forward. You're not trying to work these things out on the fly. But there's also other tools like SQL Compare is a Redgate tool that's quite good, where you can say this is what the schema should look like. It'll analyze the production database, say these are the changes that you need to make, and then apply them. I'm petrified of those ones. I mean, I trust those guys. They're smart developers at Redgate, but it's a pretty loose definition of repeatable, I think. You can do a deployment to staging, and it goes, yeah, the differences are this, we're going to apply them. And then you do it to production, and it goes, well, the differences are these ones, and I'm going to apply them, and everything breaks, because you've never tested that before. So I really like migration scripts. Might be more effort, but I think it's definitely worth it. That doesn't get over the issue of how do I undo the change if something goes wrong. And to do that, I like the idea of transitional deployments. And that's really just an acknowledgement that maybe something's going to go wrong and maybe you have to back out of it. Now, ideally, you should be able to fix that bug and move forward. But we know that's not always possible, especially if you're starting to move your existing big application towards this kind of continuous deployment. You may have to wait a couple of weeks or a couple of months or something before you can get a fix out. So the idea, and I know Microsoft has started doing this as well, is that you try to make sure that the version of the database that you've just deployed is compatible with the previous version of your code. Now, it seems a little bit of a weird thing to do, but when you deploy version 4 of your application, it means you're deploying version 4 and a database that works with version 4, but also works with version 3. So if you think about it, you deploy the application and your database changes at the same time. Let's say you deploy version 4 and some changes to the database for version 4, and then you realize that version 4 of your application actually isn't very good. So you need to pull it back. But now your database is in this state where it should be working with version 4, but version 4 is definitely not running anymore. The binaries you just roll them back to version 3 or install version 3 over the top. If you can set that transition up so that the version 4 database can still work with the old version of the application, then you're still okay. So as a more practical example, let's consider like a database table for customers, and somebody a while ago in their infinite wisdom decided that the date of birth field should be a string because, I don't know, you can assume that they made a good decision at the time. But anyway, so you obviously want to change it to a date column. But rather than just parse that, put it in a new date column and remove that column, for version 2, maybe you want to have both running for a little bit. You could even set up triggers or something like that so that when you insert a new record with the new date column, it puts a string representation back in the old date of birth column. So you've got this transitional period where the old stuff is still going to work if you need to roll back to that stuff or roll the previous version forward. It's still going to work, but then you've still got a way out. When you actually think, yes, we're okay, then down the track you can remove this. Now that obviously becomes a process problem as well. Are you just going to leave yourself saddled with all of this technical debt? Or you need to be able to build something into your process that says, no, go and remove this in a couple of versions' time when we've proven that it works. But having those transitional deployments means that it's safer to push out faster because you don't have to worry about what will happen if everything goes wrong. You can still just roll back to the previous version and you're okay. So those are, and again, it's hard. That was an easy example, but sometimes the changes that you make are quite difficult. Huge schema changes are very difficult to have a transition period. It can be done, it's just more work, and that's why everyone earns so much money, right? So deploying without drama is all about getting to a stateless deployment. You can just push out an application. If the deployment fails halfway through, it's fine. Push it out again, because you're not reliant on the state of that application at the time, the state of that environment. Just keep trying until it works. And this is something that happens with a lot of tools, deployment automation tools like Octopus and other ones, where you can do a deployment, something fails halfway through because there's a file locked or maybe you're out of disk space. So you fix that issue and then just run the whole thing again. There's no there's no point where you're like, oh, what got copied? What got ran? Or what got run? What scripts have we applied? You can just do the whole thing again. So stateless deployments, databases, look at migration scripts, and also compatibility one version back is really powerful. It means that you can care a little bit less about pushing out binaries that you might have to pull if everything goes badly. So we've kind of got our software in a better state, or we're starting to get our software in a better state, and we're starting to get our software in a place where we can deploy it a little bit more safely. And then we get to the speed part, the deploying the right stuff, which we've got here, to the end users. So we've got deployable software, and now we want to do it faster. And this is where this virtuous cycle comes in. We want to do it faster, so we're deploying smaller bits, and they're less risky every time we deploy them. And if we make a mistake, we can just push out a fix really quickly. So we want to improve the cycle time. So number one, obviously, is automation. That's kind of the first thing that anybody goes to, automating the process that you're using to deploy. And again, this comes back to step 0, where we now know what we do with the deployment, so we can start automating that. The reason we want to automate is that people tend to make mistakes. Like, who's heard of Knight Capital Group? Anyone? A few hands. I like seeing almost no hands because it's a great story. So Knight Capital Group was a software development company. They did share trading software for the New York Stock Exchange. So they'd take these big trades and then break them up into smaller pieces and find people who wanted to trade them. So they were passing through billions of dollars a day in trades. And they decided they needed a change to the algorithm that worked out pricing and things like that. So they reused a flag that had been used several years before that just wasn't ever set to the other value anymore. So basically repurposing a flag, they made the changes and they tested them extremely thoroughly, and everything worked. Everything was going really, really well. Everything worked perfectly. They needed to test it, billions of dollars a day. And so overnight, They deployed the new version to production. And then in the morning, the market opened, and about 45 minutes later, the company had lost $440 million in 45 minutes before somebody worked out that they probably just needed to hit the kill switch. Now, the reason that it broke wasn't that the software didn't work. These changes that they made worked perfectly, but the person doing the deployment deployed it to 7 out of their 8 servers. So the 8th server was running this old code that hadn't been run in 8 years and reporting incorrect values back. So the company was bankrupt in less than an hour. Even worse, they were large enough to be called like a market mover. So there were other smaller companies responding to the trades that they were making incorrectly. And so they got fined stupid amounts of money because they basically put all of these other companies in danger by trading irresponsibly. But yeah, that company doesn't really exist in the same form anymore. They went bankrupt not because the software didn't work, but because somebody made a mistake, and it happens. So people aren't good at that kind of stuff. To start doing this automation as well, don't start doing it as a big bang. Like, we know how complex some of the software is to deploy. That's why it takes the whole weekend. But there's some bits that you can do a bit faster, maybe. So if step 1 is copying like a gig of binaries and stuff to each of 10 web servers, you can automate that really easily. Like, you don't have to have somebody RDP onto all the machines and drag the files across. Just automate that little bottleneck. Then look for the next bottleneck and automate that. Tools like Octopus Release Management, any others that are there, they generally have a manual step, like a manual intervention step is what it's called in Octopus, and I think what it's called in RM, coincidentally. So you don't have to automate everything in one hit. You can have manual steps listed in the tool of choice for the things that you think, well, I don't know how to automate that, or I'm not going to automate that yet, it's too hard. And then that step is just a pointer to say, all right, now we need to go and do this now. It has the same effect as a Word document that's probably incorrect as well, but it means that it's much easier later on to take that manual step, automate it, and the process can continue without you, which is good. The ultimate aim, of course, is to automate all of the things, like automate everything you can. There's another talk I do where I talk about a pipeline, and that if your pipeline has a human in the middle, like a manual step, then it's 2 pipelines joined by an idiot. So that's what you should ideally be trying to avoid. Just have one pipeline that goes all the way through. Speaking of pipelines, this is what you're trying to really get to. So a pipeline does 2 things: automation and safe deployments. So your pipeline should really make it as easy as possible and as hands-off as possible for your code to get compiled, tested, and deployed to an environment. Now, it may not go all the way to production straight away, and in fact, until this pipeline's pretty solid, you probably don't want to do that. You don't want every commit that you make to hit production, probably. I certainly don't. So the pipeline is about automation all the way through, but it's also kind of a series of filters. It's a series of stages that give you the opportunity to prove that this application is not ready for production. So you have this build phase with your build server, which makes sure that the changes you've made and the changes other people have made don't clash. Does it compile? And then do the test pass, unit tests and acceptance tests and all of the other ones, integration tests and all of those things. Do those tests pass, or have you broken something? Have you regressed a bug or something like that? And then deploy it to another environment and try it in a real web server or something like that rather than your dev machine or the build machine. Do the tests still pass? Does the UI look the way it does, or have I screwed that up somehow? Can we talk to the third parties? Like, can we talk to the database? Can we talk to that web server? Or has the network gone weird or something like that? And then did the process that we used to deploy it, did that work? Or are we missing a step? And then by the time you get to production, if it's passed through all of these filters, you're pretty confident that it's going to work by the time you get there, ideally. Now we talk about, with testing, red-green refactor. Does everybody know that one? So the idea being, if you see a bug, you write a test to prove the existence of that bug. So the test goes red, then you fix the bug, and then you make sure the test goes green. So you're testing the right thing. And then refactor is often just a, did I regress anything else? Do I need to change the way the code's written? All that sort of stuff. or red, green, red, damn it, revert is another one. So you can do that with your process as well. If you get something in production that you don't want in production, then you can add to your pipeline, prove that it stops that thing from getting all the way to the end, and then you know that you're not going to make that same mistake again. So for example, if we have that issue where the deployment failed because there was a file locked, then maybe we need another step in our pipeline to say, during the deployment, check that this file isn't locked, and if it is, unlock it, and then continue, or something along those lines. So stop the same errors from happening again. So ideally, by the time you get to the end of this pipeline, just before you get to production, you know that the software is at a reasonable quality. It's passed your tests, it compiles okay, it deploys okay, and it's going to work. If you want to move even faster, though, and I wouldn't recommend this as like step number 1 necessarily, but it's a really good thing to do, is to work with feature flags. Does anybody have feature flags at the moment? Oh, okay, quite a few people. So in general, a feature flag is just wrapping some changes in a flag. Think of it like an if statement, basically, saying, if the flag's turned on, then do this. And these are the changes that I'm making. If the flag's turned off, do what you were doing before. That's kind of a basic way of thinking about it. And because we have all of our configuration external, it means that we don't have to worry about recompiling the application with our code in it and then making sure we recompile with the changes out of it so it'll work as well. We can just flick a switch in configuration. So when we deploy to test, we can turn it on, test it, but then we deploy it to production and you can deploy it with the flag turned off. And so the old code will still run. So production, what this means is production has your unfinished or you think it's finished code running in it, which allows you to test your code in production, which is generally not a good phrase to use, testing in production, but it can be really powerful. So Facebook does this a lot. Facebook deploys on a daily basis up to 500 changes on a daily basis, and they have like hundreds of thousands of developers working on the same code base at the time. And it's PHP to make it even worse. But they wrap everything they do in feature flags, and they push it out to production, and then the developer who worked on it can turn that flag on for themselves and see what happens. And if it's wrong, turn it off again. And it's in production, so you can test it in the real environment it's ultimately going to be in, but you're not impacting anybody else. Of course, your pipeline needs to check that you're not going to impact anybody else as well. But you can do that, test in production. The other thing it lets you do, which is actually really, really powerful, is it lets you separate the launch of a change or a new feature from the deployment of that change. So you could be pushing stuff out to production all the time, and then you think, this is definitely ready, we don't need to work on this anymore, and it's sitting in production with the flag turned off. Your marketing department can then say, well, you know, it's about to be holiday period at the end of the year, we're going to release this feature now, and they just flick the thing on, and it lights up for everyone. You can do this with on-premises software as well. So it's very common with web software to do this kind of stuff. But on-prem software as well, you can hide changes behind feature flags and let people download new versions and update the new versions of the application. And you can either set it on a date timer once you're confident that it's going to be ready at this date, just to light up at the time. Apple does this as well. Like if you've got OS X updates just before an Apple update, people decompile the bits that have been pushed out just to see what new features are coming in the new laptops. But they push this stuff out, and then at a particular date, it lights up. So we do that with Octopus as well, because that's an application that you install on a server. So we put code in that's, we think, probably pretty ready to go, but we want to test it in real environments. So we release builds with that behind a hidden feature flag that's off. And then maybe some trustworthy customers, we say, can you just go to the configuration file and add this line in, please, and you should see this thing light up. And they can test it for us. And if it doesn't work, doesn't meet their expectations, they can just turn it back off again. So you can do it even if you're not doing web stuff. All right, so improving cycle time, number one, automation. And I should care what product you use. You should use Octopus. But if you have a product that works for you, or even your own scripts, you can hand roll this stuff if you really want. I wouldn't recommend it necessarily, but have some automation process to do the things that humans are bad at. Start building up that pipeline that automates the build, test, deployment to your test environments, things like that. So start doing that, and then add to it, add the tests, add the acceptance testing, add UI, and try and remove people from that pipeline as much as you can. And then feature flags if you want to move really fast as well. So a little note on the culture of DevOps. So I've heard plenty of people say that DevOps is not a process or a product or anything like that. It's a culture change in your organization. And I think there is definitely value in that statement, and it's pretty much correct. But I don't think it's very helpful for somebody who is already working on software and then they need to get their process better and they need to deploy faster and safer and things like that. I don't think it's very valuable to say, well, you just need to change the culture. Has anybody been in an organization where somebody comes up and says, oh, by the way, we have an agile culture now? Right. Yeah, exactly. You can't just change the culture of a company straight away. Somebody can't come in and tell you, we are now a DevOps culture. It doesn't really work. And you should say, also, don't change anything. Your new title is Senior DevOps Architect. Don't do anything different, though. You can't just change the culture, but there are some things that you can look out for to prevent you going in the wrong direction. And again, I want to talk about silos. So, yeah, if there's two teams, so let's say there's a dev team and a test team and a DBA team and an ops team, right? The developers write their code and they make their database changes and then they submit their changes to the DBAs for approval. I've worked in a company like that. We weren't even allowed to see production databases. We just submitted our database changes to the DBAs, the scripts, and then waited for their approval. How many times do you think it came back without changes? None, ever. They need to justify their jobs. So that's one team, but we were throwing things over the fence, and then that was fine. We'd write instructions for the ops people to deploy, and so that would get thrown over the fence. You know? So you're not talking to each other, you're just throwing things over the wall. And usually the solution to a problem isn't to build a wall for some people. So yeah, try and avoid these silos as much as possible. There shouldn't be a DevOps team unless that DevOps team consists of the developers and the operations people. Like, it should be the same people doing that work who are actually talking to each other, not a new department. If you're in an organization where you don't have control over that scenario, though, which is a lot of people working in Brownfields DevOps, if you're a developer who's being told to move the tickets from this side of the board to that side of the board, you're not going to be able to convince management not to have silos. There's organizations where people's jobs seem to rely on them being the only person who holds this power to modify the database or to change this server. And you might not have control over that. Doing something like establishing a task force is kind of a nice way of getting over that communication problem without having to change the organization. If you can convince your manager that you need a task force to prevent this thing that happened the last time we deployed, even better if you can make it sound like it was their idea, then you can overcome these issues before they happen. So when you do these Saturday deployments and everything goes horribly wrong, the last thing you want to do is sit back and say, right, what went wrong? How can we prevent it from happening next time? But really, that's the ideal scenario to say, look, these things went wrong. Maybe we as developers didn't give you enough information. Can we establish a couple of people from each team just to sit on a regular basis and work through these issues so that we can give you better instructions next time, or that we can write better SQL scripts to give to the DBA team next time. Tell us what we've done wrong. We'll tell you what you can do to help us, and you actually have this communication happening even if you can't restructure the organization. The word task force is actually quite powerful as well. People think, oh, that's not a restructure. It's just, it seems modern and, you know, change of culture because we're in DevOps now. So you can do this stuff without having the power to change the organization. The other thing you need to really, really focus on is fixing stuff for next time. It's really, really easy, especially if everything goes wrong, to just fix the stuff as you go. Yes, we need to unlock that file, fine, we'll do that this time. And then as soon as it's done, you wash your hands of it and you go back and you do your development. What you really, really need to get into your team is the idea that if something goes wrong, you need to prevent that from going wrong the next time. So build that step into the pipeline now. If you release a bug, make sure there's a test around that thing so you don't release that bug anymore. And this can help the culture change as well. But for the most part, the culture will start to change once you start being able to deploy faster. You know, the idea of, well, I need to push this code that I'm working on out to production. Maybe I can just wrap it in a feature flag and turn it off so I'm not impacting anybody else. These changes will just start to take place once you start making these small changes to what you're doing. But yes, try and avoid silos as much as you possibly can. The word task force is powerful, especially if your manager thought of it. Fix any problems that occur for next time so they don't happen again. These three things can kind of push your organization to a better culture as well. So I just want to go back before we stop. I'm going to leave a bit of time at the end just so we have time for questions, because I understand everybody's situation is completely different. And you might have listened to 5 of these tips and said, well, that's not going to happen. There's no way I can make that change. So I want to hear about your individual scenarios as well if you have questions. But going back to this definition, working together to get the right stuff in the hands of users faster. So this is really all it's about. And I'm not going to tell you need to have this meeting at this time, like in Scrum, or that you need to have this team structure necessarily. Work out what works for you, but make sure you're working together as a company that wants to push the right stuff out to the users on a faster basis. That's how you get to where you want to go. So we looked at why we bother at all, whether it's a buzzword we can just ignore, and hopefully the ideas behind it are not something that you should ignore. You don't have to call it DevOps if you don't want to. It's going to be like agile software development, where it's just software development now. Like, that's the way that people do the work, hopefully. DevOps is going to be, well, that's how we do the work soon. So we establish a baseline with our application so we know what's happening with our process. And then try and make small changes to the architecture of your application to get to a better state so your application is more deployable. And that means externalizing dependencies, the configuration and things like that, so that you can make these changes and deploy the same bits each time. Then try to get better at actually deploying those bits to the target machines that they need to go to, where it's not a drama to actually deploy the application. And then finally, once you start going down this path, you can start improving that cycle time so that you're deploying, rather than once every 3 months, you're deploying on a daily basis or an hourly basis. Now, one important thing, continuous delivery and continuous deployment as well. Continuous delivery is kind of being able to deploy your application at any point. Continuous deployment is when you do. Continuous delivery is much more important. If you hear about people saying, well, we deploy 80 times a day, like I think, is it Etsy, I think, deploys to production 80 times a day, which is great, good for them, that's fantastic. But like at Octopus, it's an application that people install on their machine. We don't want to deploy a new MSI 80 times a day, but we could. It takes us half an hour to go from a commit all the way through our pipeline to get production-ready application, and we can click a button, and within that half an hour span, it can be on the servers, blog post up, the change sets, the GitHub comments have changed, the issues are closed, the binaries are there, new versions are up, all that sort of stuff inside 30 minutes. So we could deploy 50 times a day, but we don't need to. We don't have to. It means that if there's a bug, we can fix that bug in 30 minutes after we've fixed the code. We can push that bug fix out in 30 minutes. So we can do it, but we don't have to. And then as you do all this sort of stuff, you'll end up seeing this culture shift, but there's things to watch out for, silos especially, and making sure you kind of fix the things that went wrong so they won't go wrong next time. That will definitely contribute to the culture. So that is all I had for you. We've got time for questions, but thank you. All right. Anyone have any questions about this? Yeah. How do you prevent feature flags from, or feature switches or toggles from bloating the code base? That kind of comes back to the process that you have, your development process. Ultimately, feature flags are a great way to generate technical debt. And I gave the example of Facebook. They wrap everything in a feature flag. They have made the decision as a business that they don't clean up old flags that are never turned off anymore. That code exists in their code base. They have hundreds of thousands of lines of code that never get run in their code base. But that was their decision. The way their compilation kind of works is that they can filter that stuff out and it doesn't impact performance and things like that. But they had to do a lot of work to get to that point. As a general rule, cleaning up technical debt afterwards just needs to be built into your development process. So maybe you have a point at which you say, if a flag has been turned on in production for a month, then there is a literal ticket that goes on our backlog to say, clean up the remainder of that code. So that it becomes a process thing rather than a technology implementation thing, I think. Cool. Yeah. Yeah. So the comment was, as soon as there's pressure for features, the process things are really hard, and that is correct. As a developer, you often don't have control over, how you spend your time. It's about moving the ticket from here to here, right? Convincing the management or your bosses or whatever that the time that you spend doing this thing that's not a new feature is still time well spent is a really hard problem. Sometimes, I don't know whether I should condone this, but sometimes it's better to just do it and then ask for forgiveness later. That old saying that it's much easier to ask for forgiveness than permission, sometimes that can apply. Just have that as a process and say, no, this is a required process. We have that ticket on there for a reason. It's on. It's also kind of that's kind of the reason that I'm not suggesting that you pack everything up for a month and say, right, we're going to do DevOps now. There's no features. For the next month, we are going to do DevOps. That doesn't work. You need to incrementally fix these things. But yeah, that is a hard problem. I'd say if you get definite pushback and no, you are not working on anything but features, maybe just spend an hour a day doing it anyway. Maybe. Possibly. I'd be a terrible boss, I think. Or a good one, maybe. Cool. Any other questions? So we've got a couple. I'll go here first. A special library I use for feature flags? I have only used my own kind of hand-rolled stuff before, or Launch Darkly is a service, kind of a feature flag as a service. Startup out of San Francisco, because that's where startups come from like 2015, I think they started, so still pretty new. But they have some pretty cool technology that will only push the changes out to your running code. So you could have that flag turned on for 1,000 machines, and it runs through that code to say, do I run down this code path or this other one? But it will never call back to the server unless that changes, and then it pushes those changes out. So it's actually a really cool tool. Pretty easy to use as well. I did a talk on deploying straight to production last NDC Oslo, and from never having used that product before to having a working demo with a couple of feature flags was about 40 minutes. Libraries for all different environments and stuff like that. So that's the one that I've used before. But I've also hand-rolled. I mean, it's an if statement. It does get complex, but yeah, that question of whether you store it in the database or config files or something like that. I mean, that's a third party place to store that configuration, Launch Darkly. So that could be your thing. Or you could build an admin page that just sets the database record to on or off. It's not a terribly difficult problem. It's just you need to make sure you get it right. Yeah. There's a question here. Yeah. So the question was about different permissions for users. So when you're a developer working on the code, you probably have full admin rights of the application that's running. But then when you deploy it, you don't see the same thing that your customer sees. There's two kind of ways to handle that, I think. Feature flags is one where you can just flick it off again and say, oh, we didn't realize that change was going to affect you that way, so let's just turn it off, we'll go back to the drawing board. But probably better is to build that into your pipeline. So have tests that test all of these things as a particular role. So building that into your pipeline as another filter. Do the test pass as an admin? Great. But do they also do the test also pass as somebody with these permissions? So there's obviously going to be a lot more work in doing that. And it's always a balance between, is it worthwhile preventing that error, spending a few hours preventing that error, or is that an error you're willing to accept and you'll just deal with it when it comes up? That ultimately is kind of a team management position, what you spend your time on. Cool. Any other questions? Nope. If you want to see a slightly less polished task, I hope you're coming to PubConf talk. I hope you're coming to PubConf tonight. And yeah, that's me. Thank you very much.